Hey guys, so for today's notes, we're going to be in your notes packet on page 7, and we're going to be looking at starting to factor with quadratic functions, starting today with finding the greatest common factor and factoring that out. Okay, so let's begin. Okay, so the GCF, that stands for the greatest common factor, and it's the largest monomial that can evenly be divided into all of the terms in your polynomial or your quadratic function or whatever. So remember, this monomial means we're looking for a single term, and it has to be able to divide into everything present. So it may just be a variable, it may just be a constant, it may be both a coefficient and a variable. Okay, so if you're just looking at values, at numbers, it's going to be the largest number that can evenly divide into all of them. If there are variables present, then it's if that variable is present on all of the terms in your polynomial. For example, if they all have x to some power, then the variable in the GCF will be the smallest exponent that they all have in common. So for example, if we have 12 and 20, and we want the GCF of those two numbers, the GCF is going to be the smallest number that divides evenly into both 12 and 20. Okay, sorry, the largest number that divides evenly into both of them. So 1 divides evenly into both of them, 2 divides evenly into both of them, but also there's 4. Okay, if you divide 4 into 12, you get 3. If you divide 4 into 20, you get 5. And 4 is the largest number that can divide evenly into both of them. If you have 4x and 6x squared, you first just look at the coefficients. So you look at the 4 and you look at the 6. And the GCF for the 4 and the 6 is 2. Then you look at the x and you look at the x squared. Okay, and with those, because they both have an x, you're taking the smallest exponent that they have in common. And remember that this x is really like an x to the first, which means that its exponent is smaller than the x squared. So we can take out an x. So 2x divides evenly into 4x, and 2x also divides evenly into 6x squared. And so that is the greatest common factor of those two numbers. So the steps for factoring out the GCF, once you have identified what that GCF is, you find the GCF and you write that over to the left. You put it out in front. Then you're going to put parentheses, and you're going to basically put the leftovers in those parentheses. So when we are factoring, it's like we're taking that greatest common factor and we are dividing everything by that number. And after you divide it out, inside the parentheses, you're saying what is left of every term after you have divided out. Now, the trick is you're dividing the coefficients, so you're dividing the numbers in front. But when you divide with a variable, the trick is that you're subtracting the exponents. So for example, if you have something like x to the third, and let's say you have factored out an x to the first as part of your GCF, the shortcut for this, because it's like you have x times x times x over 1x, and we say that just one set of those has canceled, leaving you with x squared, the shortcut is to say that you are subtracting the powers. So you say it's x to the 3 minus 1 power, or x squared. Okay, so subtract the exponents because that's the shortcut. But you're dividing the coefficients, the numbers out in front. Now, sometimes you may be asked to factor out a GCF and it looks like there's not one, okay? And you technically could say there's not a GCF, or you could say the GCF equals 1. And if the GCF equals 1, that means there's nothing other than 1 that you can divide into everything. Because if you divide everything by 1, nothing changes. right? So if you're dividing it by 1, nothing changes, and you're just left with that same polynomial, and that means we don't even bother to write the 1 out in front. Okay, so let's look at some examples of factoring out the GCF from a few different polynomials. Okay, so we're going to factor out the greatest common factor. So our first example, and we're on page 7, is 4x squared plus 8x plus 2. So we first look at those numbers out in front, the 4 and the 8 and the 2, and we can factor out a 2. Okay, then you look at the variables. We have an x squared and we have an x, but our last term doesn't have any x's. That means we cannot factor out an x as part of our GCF. So the GCF here is just 2. But now we have to put the leftovers. So we've identified the GCF. Now we're going to put parentheses, and we're going to put what happens if you divide everything by 2. So we start with that 4x squared. If we divide a 4x squared by 2, the 4 divided by the 2 leaves you with a 2, and the x squared isn't really affected by it. Then we go to the 8x. 8x divided by 2 is going to be plus 4x. Because remember, we're dividing everything by that 2. Now at the end, there is a plus 2, but remember, we're not subtracting, we are dividing. 2 divided by 2 is 1. So an important thing to note is that inside the parentheses where you're putting your leftovers, basically, you're always going to have the same amount of terms as you started with. So we started with a trinomial with 1, 2, 3 terms. And notice inside the parentheses, we still have 1, 2, 3 terms. That will always happen because you're dividing, and so nothing cancels out when you divide. Even if you have 2 divided by 2, it still leaves you with a 1 because you're dividing it away. So that's it. That is factored. We've taken out the greatest common factor there. To check your work on this, you can just distribute it back. 2 times 2x squared is 4x squared. 2 times 4x is 8x, and 2 times 1 is 2. Okay? So all you're doing is you're dividing. You're just dividing out a number. That's all factoring means. Okay, so for the next one, we've got 10b minus 15. So you can look at the numbers out in front. We've got a 10 or we've got a 15. So 5 divides evenly into both of those. And for variables, 10b has a b, but 15 has nothing, which means we can't take out a variable. Remember, the variable has to be on all of the terms. So then we put parentheses for our leftovers, and then you divide. So 10b divided by 5 is 2b. And minus 15 divided by 5 is going to leave you with a minus 3. And that's it. You have factored out the GCF. Remember, you could just do a quick mental check. Okay, 5 times 2b is 10b. 5 times minus 3 is minus 15, so you're golden. That's it. Okay, the last one here, we'll look at those coefficients first. We've got a 2 and a minus 3 and a minus 12. Okay, well, here's the thing. It has to divide evenly into all of them. And you know 2 is prime because it can only be divided by 1 and 2. And 3 is prime because it can only be divided by 1 and 3. So the only number that divides evenly into both 2 and 3 is 1. Forget about the 12. The 12 is just there to distract you because you might say, oh, well, 2 goes into 2 and 12, or 3 goes into 3 and 12, and that's great, but nothing goes into all 3 of those numbers except for 1, and we don't have to factor out a 1, right? Because it wouldn't change anything if you go through and divide all the numbers by 1, they won't change. You can look at the variable as well. And again, you've got an x squared and you've got an x, and then you have a constant, something without a variable at all, which means there's nothing to factor out there either. So here we can just say the greatest common factor is 1, because if you divide everything there by 1, nothing will change. Okay. Next row. Okay, so we are going to factor out the greatest common factor of these now, and if we look at this first one here, we've got 2x to the third minus 5x. 2 and 5 are both prime, so again, we're not going to be able to factor anything other than a 1 out of those. But both terms have x's now, which means that now we'll be able to factor out a variable. So even though we can't factor out numerically anything other than 1, they both have x. We've got an x to the third power and an x to the first power, so we can factor out an x to the first power. So now, remember, if we go through and divide everything by x to the first, it's understood to be to the first power, you are subtracting exponents. So the 2 on 2x to the third is not affected. X to the third divided by x to the first is x squared. Minus 5 is not affected, and then x to the first divided by x to the first cancels. So you just are left with 2x squared minus 5. Now, you can check these by distributing, but another thing to check for is to make sure there's no other factors left in common inside the parentheses. So by that I mean, look inside, you've got 2x squared minus 5. So there's nothing other than, you can't take anything out of the 2 and the 5, and the x squared and the constant doesn't work. So that's how you're sure that you've gotten the GCF. Okay, the next one here, we've got k to the third plus k to the second plus k. There are no coefficients, they're all 1s, so you can't take anything out there. But they all have at least k to the first power, so you can take out the k, leaving you with k to the second, because remember you're subtracting exponents, plus k to the first now, so you don't have to write the 1. And then k divided by k is 1. So there's GCF factored out. So again, there's nothing in common inside those parentheses that I could take out. Again, that's how we're sure that the factor we took out is the greatest common factor. There's nothing left on the inside that you can work with. Okay, we've got 3x to the fifth minus 2x to the third plus 7x squared. 3 and 2 and 7 are all prime, so there's nothing we can take out of the coefficients, but they all have x's. So we've got x to the fifth, x to the third, and x to the second, and the smallest exponent that is available is x to the second. So we can take that out. Remember subtracting exponents, so it becomes 3x to the third minus 2x plus 7. Okay. And then the last few examples. Now we practice taking out variables and we practice taking out coefficients. Let's get out both. Okay, so if we have 12y squared minus 6y, look at the 12 and the 6. And hopefully, once you do enough of these, if you know your times tables well enough, most often they will just kind of jump out at you. We can divide both of these by a 6. Okay. Then look at the y squared and the y. They both have at least y to the first, so we can take out a y. 12y squared, so 12 gets divided by the 6 and leaves behind a 2. The y squared gets divided by a y to the first, leaving behind 1y. Then we have minus 6 divided by 6 leaves you with a 1, and y divided by y also cancels out and just leaves you with a 1 in the back. So again, make sure that you have the same amount of terms inside the parentheses, 1, 2, as you started with in the beginning, 1, 2. Okay. All right, we have 3ab minus 3ac. So a few different variables this time, but the same rules apply. You're just going to go through it letter by letter this time. So we can take a 3 out of both. We can take a out of both. But b is only in the first term and c is only in the second term, so those cannot be factored out. So you're taking out a common factor. They have a in common and they have 3 in common. So the first term, the 3 is gone, the a is gone, the b is left. The second term, the 3 is gone, the a is gone, the c is left. Remember, you should be able to distribute your GCF back and get what you started with. So 3a times b would be 3ab, excuse me, minus 3a times c will give you 3ac. All right, last one. We've got 7 and 7 and 7. They all have 7, so we can take that 7 out. There's your 7. And then we don't have x's on all 3 terms, so we cannot factor out an x. You've got x to the second, you've got x, and you've got just a constant. So that leaves you with, if you divide the 7's away, x squared plus x plus 1. And that's it. So factoring out a GCF, look at the coefficients and look at the variables. It has to be the same letter, okay, for your variables. And, excuse me, look for the smallest exponent that that variable has in common. And remember, you're dividing, so terms never cancel out. And you should have the same amount of terms inside the parentheses as you did in the original polynomial. And that's it.